My name is Bob Stellflue. I'm a senior design engineer at Team Associated. I've been with Associated for about 10 years now. My forte in the past was in the on-road side, and I've delved into the off-road side here for the new B5 buggies. So they've been a big undertaking, a complete new design with almost all new parts. And they're, of course, the successor to the overqualified B4. We had 5 consecutive World Championship titles in its 10 or 11 year existence. So this was a fun project to get involved in, and it was an honor for me to be able to work with it. So I was the lead designer on the B5 project, and that included the B5 and the B5M. Cody Newmandahl came in at the end of his college career and the beginning of his work career to help out with the mid-motor version. So between the two of us, we tackled the design work, and of course we had extensive input from racers and the team and hobby shop owners, this sort of stuff, to lead us down the right path. So in the gist of it, we took what we had for an excellent buggy in the B4 and we moved forward with that. So in the rear motor configuration, there's very few things that are different. What we've done is we've optimized and refined what we had before. So we worked basically on the shortcomings. Some of those were in simple things like the tie rods or the ball cups on the end of the tie rod. So those, of course, were addressed to be more durable and to have a better fit. And again, like I said, all the while trying to make sure that we didn't leave anything behind from that B4 car that was such a good chassis. So we've added improvements all the way through. We've kept the big bore shocks on the car front and rear. They're hard anodized, threaded aluminum shock bodies. We've gone to a plastic cap on the top end of those to help keep the cost down. We've got more adjustment in the car front to rear. We have adjustability in the front that we didn't have with kick-up angles, 25 and 30 degree. We have trailing axle adjustments on the front end. We have more length options on the back end. Again, the whole way through, durability and ease of maintenance were considered. So on all these pieces, we look to that end. So suspension arms are beefier than they used to be. Caster blocks and hubs beefier than they used to be. Bearings are bigger. Ball studs are bigger. And even down to the metric car, the metric screws are bigger than the standard screws. So we've added durability where we can everywhere. And like I said, just working back and forth with the consumers and the racers, trying to hit the marks everywhere. So the adjustability was put in there. Shock positions were refined just a little bit, but geometry essentially came over from the B4 and went that way.
So when you say that you were aiming at what the consumers wanted improved from the old car, what specifically performance-wise do you think that was? Like, what were they looking for?
Honestly, there wasn't much in performance. More than anything, it was durability. Durability and ease of maintenance. Okay, and the key thing on all that, or the most important thing that came back, was the ball cup, the tie rod and the ball cup. So that was the first thing on the list to adjust that. So we have a thicker section around the outside of the ball cup, the eyelet there, that really helps hold things together. And we used that same low friction material that we did with the updated version of the B4. And then the guys were really looking for ease of maintenance. So we addressed that as much as we could through the car.
Well, we've got a mid-motor car in front of us right now. In what ways is this car more easily maintained, let's say, than the previous car?
Well, one of the things we looked at, and the consumers and the racers were telling me over and over, was that we wanted to minimize the number of screws through the bottom of the chassis. If nothing else, to get to those screws to repair something, you have to always dig dirt out of it. So on both the mid-motor and the rear motor configuration, we've done what we could to minimize that. So even if you look at the servo and the way the servo attaches, the screws go in top down. So it keeps dirt from getting into the screws and helps you with maintenance because you don't have to flip the car over to get to it. The same thing on the back end of the car with the transmission cases. The way that they assemble is a little bit different. It used to be that the motor plate would essentially sandwich the transmission cases together as a structure. Of course, then when you took it apart, the motor plate would fall off, things would get misaligned, and it was kind of messy. So we went through and refined that just a little bit. Now the motor plate fastens to one half of the gearbox by itself. The other half of the gearbox comes on as just a cap, so it makes it easier for you to get in and maintain the differential. You pull that thing apart, the motor can still hang off the motor plate, and everything can be there where it needs to be, and we pull that cap off, and the differential comes out. So at least those couple features, on top of what we already had for the B4, which was was a pretty well thought out platform. So assembly methods into the B4 rear motor were kept very much the same as say the assembly methods with the B5 rear motor were kept the same as the B4, but we've gone to eliminate some of these screws to make that maintenance a little bit better.
Well, that was a question that I had for the guys that pick this kit up, and I know that a lot of them are going to. Is it going to be a typical associated building experience? Are they going to feel like they're building a familiar car, or is it so new that they're going to kind of have to go a little bit slower?
It should be very familiar, very familiar. And again, this was kind of brought out with the constraint that the B4 was such a good car. So when we went forward to the B5, we didn't want to lose anything by changing the way these pieces assemble. Of course, as always, we try to improve on what we can with assembly manuals and the way that things are pictured and how, so that we can go forward and make it even better than it was. But this should be an associated build, no different from any of the other cars.
So one of the things that I see first off that you actually pointed out earlier is the steering rack.
Yes.
Maybe you can describe the steering rack for us.
Yeah, so the steering rack that we did here is a little bit different than what we had on the B4 platform before. We put more ball bearings in it. Basically, it has 8 bearings to support the bell cranks. And that keeps the system far more tight than it used to be with a hat bushing on the one end. And then we've gone further to put a horizontal ball stud on the output side of the steering rack. And this just allows us a more fine adjustment of Ackerman. And it also helps us in compensation of trailing axle. As we change trailing axle by 1 millimeter, we need to change the steering rack output by 1 millimeter. So having these horizontal ball studs allows us to basically combine the two changes together without having a detriment. Anytime we do the tuning on these cars, of course, as engineers, we want to isolate variables and make sure that we're only testing one thing. So when we change trailing axle, we want to make sure that we're going to have the same Ackerman that we did to begin with. We don't want to change trailing axle and Ackerman. So not only does this keep us on that realm of being able to change one thing at a time, but it gives us a little bit finer adjustment for that Ackerman alone if we just want to tune with that. And then again, with all the bearings in the steering system, it's got to be one of the tighter and more true steering systems you're going to see on two-wheel drive buggies today.
So more generally speaking, some people may wonder, like, why did Associated decide to do 2 cars? Like, why are there 2 kits? Do you first question is, do you anticipate that people will buy both? And second question is, what were the design objectives for each one?
Right. I don't necessarily think people will buy both. From what I've seen at the local tracks and from the people I've talked to, hobby shop owners and distributors, racers, everybody we can talk to, more often than not, you'll have a car that works at a track and at a venue. So these guys will typically run one car and only one car. Now, the way that we set this up, being that the cars are both set up as a team kit where we pulled out some of the high-dollar parts, aluminum shock caps, titanium turnbuckles, the price points for these cars sit to the end where you could probably buy both of them for about the same amount that you would buy a car that would be convertible. But to our end in the design, it was better for us to have 2 different cars. And this allowed us a no-compromise end to it. So we heavily looked into making both the cars into one. And the constraints for where the motor sits on the back of the car would make a detriment in the rear motor version for both arm stiffness and chassis stiffness. And with the B4 working so good, we didn't want to throw that away. So instead, we decided to make 2 independent platforms so that each one of them could be optimized.
And just generally speaking, because I know that every track's a little bit different, but when you think about the mid-motor car versus the rear-motor car, what performance traits and track types do you have in mind for those cars?
The mid-motor car is going to be more tailored to indoor track facilities where the grip is higher and the corners are a little bit tighter and the track is more well-groomed. And this basically is because of the overall aggressiveness that the mid-motor car will bring. Most of the racing that we'll do will tend to be indoors on these type of tracks, so the mid-motor will probably be favored. But there are conditions when we go outdoors, and the tracks are bigger tracks with bigger corners, and the conditions are more blown out, so to speak, that the rear motor car will really shine. And even to that end, depending on the skill level, there'll be times when the rear motor car is still the way to go. So the heroes will bring that one out when they really need it and the track is really, really bad. But beginners, sometimes that rear motor car is the way to go right from the beginning. So they are kind of tailored to 2 different track styles and driving styles, that's for certain. But at this point in the game, we don't know which one is going to be predominant. I mean, I'm suspecting that we'll see more of these mid-motors, but we won't know until it plays out. Yeah.
I think that with the mid-motor popularity and with the Worlds and the high-grip tracks now, some of the guys that may have just started to get into the class think that that's what you have to have.
It's a fad.
But the fact that Associated's making both, I think, indicates that you guys know that it's not always the answer for everything.
Right, it isn't. There'll be plenty of times when that rear motor car is going to be the way to go, and we didn't want to lose it. No different than we didn't want to not have the mid-motor version. So, and we took each one of them as their own with no compromising. This is probably the best way to do it, especially when we can hit the price point like we have,
So when people look at the pictures of this car, they're going to see some interesting-looking batteries. Can you tell us about the batteries on the two cars?
The batteries that we use in the cars, or the battery configuration, is basically driven from the ROAR rules, which state that you need to use or be able to use a full-size battery in the car. So this would be a full-size stick pack or a saddle pack. In that those batteries should fit in there at all conditions, and the only thing that can be changed to run a different pack, say a shorty pack, would be a piece of foam in its spot. So we went with that end, and we designed the cars accordingly. So in most of the situations, I think you're going to see shorty packs run in these cars with foam around the outside so that it fits the rules. But in some of the situations, we may want more weight in the car. So we'll run either saddle packs, which are bigger and heavier, or the square pack. The square pack is the same size as the saddle pack, it's just in one, so it removes that jumper. That jumper wire is a lot of resistance and can really detriment the performance of the battery. So the car will fit 3 packs, 3 battery styles, in either configuration, mid-motor or rear motor. And that's the square pack that Reedy offers, which is the big, bad, heavy one, and then we have the saddle pack, which is the same size and weight as the square pack with the extra jumper, and then we have the shorty that will go in there with the foam pad. So the short pack, of course, is the lightest, and in most conditions in indoor racing, that's probably what we're looking for. When we go outside and the tracks aren't as good, maybe we want the square pack that's bigger and heavier.
So for a guy that's upgrading his car from a B4.2 to the B5, are they going to need any kind of different electronics, different size electronics? Is the basic footprint for the receivers, speed controllers, servos, are they going to be able to convert, basically take what they've been running and move it over to the new car?
Yeah, electronics should convert fairly well. Some of the guys, of course, in the end of the B4 and running it, some of them were using a longer battery pack, the full-size stick pack, and then they would put the speed control up on a shelf above the battery. We did a lot of developmental testing into the B5 to prove whether or not that was a worthwhile feature to have. And through all the testing that we did on the indoor conditions here, we were better off to keep that weight low. So some of these guys that were still on that sort of fad or trend of running that long battery would need to get a different battery to put into this car, either a shorty pack, a saddle, or the square pack. The rest of the electronics shouldn't be a problem. We basically fit in all the different kinds in what we can. The rear motor car, we have a second receiver shelf, a plastic shelf that can go over the back end if the speed controls are abnormally large, outside of what most people would run. Then that receiver can go up top. On the mid-motor car here, we have more than enough room to get all the electronics in there. So it's.
I'll make sure I'm still going here. Yeah. So another question people are going to have, and I hear this debated at our local track at Hot Rods where I race all the time: gull wing arms versus the flat arms. Maybe we can get into that a little bit.
So there's a lot of things that go into that. Where the suspension arm is as far as an angle, straight, gull wing, or with a riser on the top, will certainly change where the shock mounts on the shock tower. In the past, that was a predominant factor. So say with a racing truck, a stadium truck, it was very important to keep the body looking right, that the shocks were close together at the top. In order to do this, this required a riser. So you look at the T4 has a riser on that front suspension arm, and then it has a narrow tower up front. Okay, and then you go backwards on the other end with the B4 on the back end of that car, it uses a gull wing arm. The reason for that was that the gull wing arm drops the shock and makes the shock tower wider to keep the shock away from the wing on the car. Okay, so a lot of these things were done in the past. Even though lever ratios and things were the same engineering-wise on the shock, they were done for packaging. And through the course of testing into 8 scale, we realized that there was actually some other things going on here, something that happens in a dynamic situation when we involve time and not just static at one point in time. And that would change the handling. So we did what would be the easiest way to test this was with the short course buggy. we could wrap up into that design a gull-wing front arm to test back and forth on a truck or the stadium or the short course buggy, gull-wing versus riser. And we found right away that the gull-wing arm has a softer progression to it, and that the riser arm or the flat arm has a stiffer progression. So there will be a handling difference between them on top of the position of the shocks on the tower. And we did both gull-wing front arm and straight arm on the cars for that reason, so that we had a tuning adjustment between the two. Now, it's not saying that one is going to stay with one car. If a guy wants more steering, he'll run a gull-wing arm, whether it's on a mid-motor or whether it's on a rear motor. If a guy wants a little bit more stable car, he'll run a flat arm. We pictured both of them on each, or excuse me, one of them on each car because they're options, you know. But they do take an arm and a tower go together.
So there's not necessarily a mandate, not a mandate, but a preference for the mid-mount car with gull-wing arms versus the rear motor car with flat arms. That's just how they're
That's just how it's photoed. We had two cars and two sets of arms, so just to show that we had both of them. We showed on each, rather than a gull-wing and a straight arm on each car.
Right, because the conspiracy theorists out there will love to try and figure out whether or not that was intentional.
So there's the end of it is that there's a difference in progression between the two, and we're using it as a tuning option. We didn't want to throw away what we had with the B4 with a straight arm and not have that as an option. So each car is pictured that way, and it's not saying that they're going to always be that way as far as what we run on the track.
Well, is there anything else about the car that we haven't touched on that you'd like to talk about? I feel like you've given us a really good overview, not only of the design, but the design intent and how it's going to feel on the track. I've driven the car. I'm very impressed with it.
Well, thank you.
Feels stable. Jumps really, really well, in my opinion. You know, jumping a two-wheel drive buggy can be tricky sometimes. I always tell people if you can drive a two-wheel drive buggy, you can almost drive anything. But this car seems to kind of lessen that gap a little bit and kind of make it a little bit.
It sure does. I mean, that was
user-friendly.
That was kind of the gist of it. If there's anything else I'd like to say, it's that, and that we knew we didn't want to stray too far from what we had with the B4 buggy, and we didn't. The B5 is very close to the same, but the improvements that we made with the durability or the fit of the links, the adjustment, or where the weight's at on the car have helped out substantially in how stable these cars are and how good they jump. And those are some of the comments that I get back from the hero drivers through testing more often than not, how fun it is to jump this car. But through and through, these are great race cars, great refinements over a B4 that was, you know, hands down the best buggy in the market. So I'm glad to have been a part of it, and I can't wait to see how these things are going to take off when the market gets them. So we're looking for great things forward from here. And, you know, as always with any of the associated platforms, we'll continue to develop on them. You know, this one will be around for a long time, no different than the B4 was. So we'll see things happen through time, some improvements. Of course, right out of the box, we'll have a lot of option parts available. So these guys that are concerned with the car being a team kit, I mean, we have these parts available for them, whether they're the titanium turnbuckles or the aluminum arm mounts or brass bulkheads or aluminum steering posts or aluminum hubs. All these things will be options. So I think we've got all of our bases covered, and I think we'll be in a good foot here with both the platforms.
Excellent. Well, we wish you the best of luck, and thanks for your time.
Okay, thanks, Stephen.
Okay, thanks a lot.